Assalamu alaikum. Welcome to my channel. My name is Mariam. Today we have a book Statistical Methods by Shahid Jamal and chapter number 3 Testing of Hypothesis. Topic test based on normal distribution, and that is also called Z test or test statistics in Z. We are learning testing the population mean mu. The procedure of to finding the Z value, calculated value, is as under. First step we have to take for finding null hypothesis and alternative hypothesis. This is given in the question. We have to find out what is null hypothesis and alternative hypothesis. Okay. Then second, level of significance. This is also given in the question. Test statistics. There's a case A, Z, and this is a X, population mean, and this is mu, null hypothesis, and this is sigma, standard deviation of population, that is known, and under root n. N is the size of sample, may be large or small. When the standard deviation of population is known and size of sample may be large or small, around 30, n is greater than or equal to 30 or n is less than 30. We use this formula, and we have case B when the population is normal or not. Any population, standard deviation of population is also known, and sample size is larger than 30, greater than or equal to 30. So we use same formula. But if we don't know the standard deviation and of a population, okay, standard deviation of population, here is a population and here is a sample. When the standard deviation of population is not known but the standard deviation of sample is known, that is S, so we have to write here S, not sigma. This is the second case, and S can be calculated by this formula. And note that the sample size is large enough and is greater than 30. Okay, so we have a question now, and there is also things from calculations and the critical regions. So in question I will tell you about this. Example 3.6. An electrical firm manufactures light bulbs that have a length of life that is approximately normally distributed with a mean 1600 hours. That is a mean of population mean, and standard deviation of 18 hours, that is population, standard deviation of population. So test the hypothesis that is mu 1600 hours against the alternative mu is not equal to 1600 hours. If a random sample of 30 bulbs has an average life 1576 hours, use a level of significance. This is alpha, sorry, and this is sample of size n, this is h naught, this is h1, and this is a sample of this is a average life, so mean. Now, solution. Here we have a first step, which is find to null hypothesis and alternative hypothesis. Null hypothesis represented by H naught and alternative hypothesis represented by H1. In the question, how to find what is null hypothesis and what is alternative, here we have a line statement. Test the hypothesis that mu is equals to 1600 hours. Null hypothesis is basically mu, which is 1600 hours. Okay, and against the alternative, mu is not equal to 1600 hours. Okay, H1 and mu naught is equals to, is not equal to 1600. Okay, so this is, we have a difference. This is mu and this is mu naught. Okay, in alternative here we use H mu naught. So this is a condition. If mu is equals to 1600, then alternative is mu naught is not equal to the value of 1600 hours. Okay, then this step is complete. We have a second step. Second step is level of significance. Which is given alpha is equals to 0.01. Okay, and the third step is test statistics. So in the test statistics we have to find out the case. Okay, so here we use book because I don't write the cases. Okay, so here we have a case A. We use case A because population is normal. Okay, and the standard deviation of population is known, that is known 18 hours. Okay, and what is the size of sample, maybe large or small? This is a 30, that is a greater or equal to 30, so we use case A formula. Okay, we have to write the statement. So since sample of size sample of size is large, is greater or large, is large, and the standard deviation of population is known. We use Z statistics. Okay, so where Z statistics is z is equals to x bar minus mu n. X bar is sample mean, and mu naught is equal to mu in null hypothesis. So that is a null hypothesis, and the sigma is S D, standard deviation of population, and is sample size. I hope that is clear. Okay, so step 4 is calculations. So calculated value, this value it's 80, no, sample mean, this is a sample mean 1576, 1576 minus 1600, and sigma is 80 and 30. So answer we get minus 1.64. So this is Z calculated. We have minus 1.64 value. Okay. This is not a complete question, it's a remaining. Step 5. Now that is a critical region. Critical region. So here we use the level of significance. Okay, how can we use? Look, there we have a cell level of significance 0.01 that is given. Okay, so and we have an answer z calculated minus 1.64. There is a table in the book. Okay, so level of significance is 0.01. Okay, and we have a situation here, that is alternative hypothesis is not equal to 1600, right? Is not equal to 1600. We use this this situation. So let's find out critical value of a z for one-tailed test where H alternative hypothesis mu is greater than mu naught or mu is less than mu naught. Sorry, we have not this. So next we have a critical value of z for two-tailed test. Here we have alternative hypothesis mu is not equal to mu naught. That is the condition we use, and there is a level of significance 0.01. So we have used this value minus 2.58 and 2.58, and this is a two-tailed test. Okay, how it is draw? We have a right the critical region at level of significance 0.01 for two-tailed test is z is greater than 2.58 and z is less than 2.58. So we have to draw. This is the diagram we have to draw. This area is acceptance region AR and this is two-tail test diagram. Okay, this is a CR critical region. This is also CR critical region. So when we have a two-tail diagram, two-tail test, so we have to divide alpha in divided by 2. So what is the alpha? 0.01 divided by 2, we get the answer 0.005. Okay, that is divided by 2 both side, that is also 0.5. Okay, so now we have, and this is the border minus 2.58 and this is a positive 2.58. Okay, what is the calculated value of that? Minus 1.664. And which region that, and which region this value falls? So this is the acceptance region. So here minus 1.64 falls in acceptance region. So therefore we accept the H naught. Okay, so there is a step 6, that is conclusion. So we have to write, since calculated value of z, so we have to write z calculated falls in acceptance region, therefore we accept H naught. That is the answer. Thanks for watching. I hope that is clear. Bye bye.